we're at with the first index law. So always writing and making sure when we're doing prime numbers, you want to make sure, sorry, when you're simplifying expressions, write them in prime numbers. So 5 to the power of 3 times 2 to the power of 4 times 10 to the power of 3 times that. You can add these numbers together because it's obviously 5 times 5 times 5 times 5 times 5. So that makes it 5 to the power of 5, 2 to the power of 4, 10 to the power of 3. But if you think about 10 to the power of 3, you can actually do that as 10 to the power of 3, which turns into 5 to the power of 3 times 2 to the power of 3. So if you think about it, it's actually 10 times 10 times 10, which is this. You can change 10 to be 5 times 2, which is 10, times 5 times 2, which is 10, times 5 times 2, which is 10, which is, if you want to think about it in another way, 5 to the power of 3 times 2 to the power of 3. So that's why you can actually do that. And then you can collect those at the end as well. So I think most people are pretty comfortable with index law number 1, where you're just adding them together. And that's the proof why 4 to the power of 3 times 4 to the power of 2 is really how many 4s you have times together. It's actually 5. Let's quickly, we'll move on to the next index law, index law number 2. I personally forget what the laws are, which number's what. I always got to look at them. Again, it's being able to reason with them and really understand like what is an index law and so on. And then, you know, we should be okay to get you there. Okay. Have a look at index law number 2. That is, what is index law number 2? It's dividing. So when you've got a to the power of m divided by a to the power of n, it equals am minus n. And the reason for this is if I look at like 4 to the power of 3, let's go with 5 actually, divided by 4 to the power of 2. Well, if you think about that, it's actually 4 times 4 times 4 times 4 times 4 over 4 times 4. Well, 4 times 4, you can cross cancel these out. And that's why it is. Just leaves it with 4 to the power of 3. So a shortcut is just to minus them. And that's the law there. That's why that one works. One thing you've got to think about, if people go, well, what happens if you say, and that's why this works, if you've got 4 to the power of 3 minus 4 to the power of 6, let's go with 7, sorry, divided by, not minus, that would equal 4 to the power of -4, which is correct, because what actually happens is it is 4 times 4 times 4 on 4 times 4 times 4 times 4 times 4 times 4 times another 4. These three are going to cross out with these three, which leaves you with 1 on 4 times 4 times 4 times 4, which brings us to another understanding of the log of these laws, the indices laws, which is if it's a negative, it actually represents 1 on 4 to the power of 4. And that is the same thing as 4 to the power of -4. And that's a whole other law in itself. So you still can minus them. You still can get negative ones. Again, another indices law is this one, where if it's a negative, you can actually just, if it's negative, it's a numerator, put it on the bottom, it becomes positive. The other law is if it's, say, if it was like this, to the power of -3, because it's a denominator, I can actually write it as 4 to the power of 3. We will look at that one a little bit later on. That is indices law number, I'm trying to remember. I know it's dealing with negative indices, so it doesn't matter. That's not till later on when we start dealing like with later on. But just a bit of a brief intro to that one. So don't worry if you get negative indices. We will look at this a bit later. So it's index law 1, which is really about doing this. Again, the same thing. If I've got like 10, you know, to the power of 3 divided by 2 to the power of 3, what is that? Well, 10 is really 5 times 2 times 5 times 2 times 5 times 2. I could write that as prime index numbers, divided by 2 times 2 times 2. These 2's are going to all cancel out with those, which would just leave it with 5 to the power of 3. So again, simplifying these, you really want to make sure they're in prime notation. So if you think of 10, 10 is 5 and 2. K, because it's power of 3, it's 10. This is going to be power of 3, power of 3. So therefore, I know that is actually 5 to the power of 3 times 2 to the power of 3 on 2 to the power of 3. You can cross cancel that out, which just leaves you with 5 to the power of 3. A lot easier to write like this. If you can write like that's really good. This helps develop your understanding. So if you're still struggling with it, write it in expanded notation. That's no problem. But eventually I'd like you to shift to this method and hopefully feel a bit more comfortable about writing them like that. So hopefully you can just sort of go, okay, 10 to the power of 3 is actually 5 times 2 to the power of 3. On 2 to the power of 3, I can cross cancel those out. Just have another look at a different one. If I've got 10 to the power of 3 divided by 2 to the power of 5, that's going to be 5 to the power of 3 times 2 to the power of 3 on 2 to the power of 5. Now here you're going to minus them, right? So you could write this as, so I'm just going to finish this off before I move on. So that's actually going to be 5 to the power of 3, and that's going to cancel out with that, and that's going to actually be 5 minus 3, which would leave you with 2. That's going to be 5, 3 on 2 to the power of 2. An alternate way you could actually write this is 5 to the power of 3 times 2 to the power of 3 divided by 2 to the power of 5. So I'm going to minus these, remember? So it's going to be 5 to the power of 3, and it's going to be times by 2 to the power of 3 minus 5, because they have to be the same bases when you're minusing or subtracting as well. So when you're dividing, they need to be the same bases, so that can only apply to this one. Which is going to leave 5 to the power of 3 times 2 to the power of negative 2, which is exactly the same thing as that, because when it's a negative power, I know I can make it as a positive power, just flip it around. Whoops, that's 2. And therefore that makes it 5 to the power of 3 on 2 to the power of squared. And that's where we go there. So it's a bit of extension stuff for you guys, just to sort of hopefully have a bit of an understanding, which you don't really get too much in the book, but is important to have an understanding of that. You will get those in the, you don't really get too many of those, but I do want you to be aware of that. So they're the two index laws, and sort of brings it together. Index law 3, we'll have a quick look at that one there, which is 6C. Which is you times these together, okay? Reason why, if you've got like, say, 4 to the power of 3, and then you've got that to the power of 5, if you think about this in terms of bid mass, you've always got to think of terms of bid mass when you're doing mass. First, you're going to do brackets. Well, I've done my brackets, then I'll do my indices. So if I think about this in terms of bid mass, in terms of an expanded law, it's actually going to be 4 times 4 times 4 to the power of 5. So all of this is done to the power of 5. So it's going to be, that's one of them. That's 2 of them. That's 3 of them. That's 4 of them. That's 5 of them. So if you think about it in total, you've actually got like, okay, 4 to the power of 3, if that's done 5 times, that means you're going to have 3, 6, 9, 12, 15. You've got 5 groups of 3, and 5 groups of 3 is the same thing as multiplication. Hence, why we can go 4. We've got 3 each of those, and I've got 5 groups of 3. Okay, so that means it's going to be 4 to the power of 15, and that's why we multiply these. Something that's really, I'm going to leave it there. Again, yep, so you multiply those on the outside. So what does that mean? If I've got 4 to the power of, I don't know, 8, I could write that also as 4 squared to the power of 4. Or I could write it as 4 to the power of 1. 8 is going to multiply it in. I could, if I really want to, do it as 4 to the power of negative 2, negative 4. All the laws will apply. Let's look at the power of 0. If I've got 2 to the power of 4, 2 to the power of 3, 2 to the power of 2, 2 to the power of 1. 2 to the power of 4 is 2 times 2 times 2 times 2. 2, 4, 8, 16. This is 2 times 2 times 2, which is 8. This is 2 times 2, which equals 4. This is just 2, which equals 2. If you look at the pattern here, what am I doing every time? We've actually got 1 less 2. So I'm dividing by 2 every time. Because if you go up, you're just adding a multiple of 2. So it makes sense if you're going down, you're going to divide by 2. So to follow that pattern, 2 to the power, and we're minusing 1 index every time. To follow that pattern, 2 to the power of 1 is just 2. If I divide that by 2, that equals 1. That's why the power of 0 is 1. Another proof is if I have 2 to the power of 3 divided by 2 to the power of 3, if you think about the Indices laws, we minus these. That's going to be 2 to the power of 3 minus 3, which equals 2 to the power of 0. If you think about what this is, 2 to the power of 3 divided by 2 to the power of 3. That is 2 times 2 times 2 on 2 times 2 times 2. 2 times 2 times 2 is 8. 8 on 8. Well, 8 divided by 8 equals 1. And that's another reason why 2 to the power of 0 equals 1. 2 proofs there, one looking at it. If we keep on going with this, take 1 off the indice, divide that by 2, that equals a half. 2 to the power of negative 2, that equals a quarter, because I have to divide by 2, which is really 1 on 2 squared. And divide by another 2, just to finish off my lesson. Minus 1, going to divide by another 2. That's going to give you an 1/8, which means it's actually 1 on 2 cubed. Hence, you can see why it becomes a positive indice and you can flip it over. That's my proofs. Power of 0, Indices Laws 3 as well. That's a wrap. I hope that helps you guys a little bit. Next lesson, I'll just